Everybody ready? We are on page 178. We're going to go through explain 2. I don't know if there's an explain 3. Oh, and explain 3. So we're going to do explain 2 and 3. Okay. All right. So I want to know that everybody's there listening. So can you in the chat just put good morning for me, or morning if it's not a good morning. So put morning or good morning in the chat for me. Let me know you're here and you're awake. All right, got about half of you now. All right, thank you, everybody. Okay, can you bring it here? Hey, I'm teaching a class right now, dude. Okay. All right, because my favorite thing to do is to teach with a baby on the lap. Okay, and you need to not show the joke. It gives away the answer, dude. We're going to go through a new method. All right, here we go, everyone. Hopefully you have morning, Samantha, how we got to the right place in our notes. I'm going to attempt to do this with baby on my lap. Mikey, I can't have you up here too. Okay, you can sit in the chair there. Okay. All right. So we're going to talk about simplifying radical expressions. Okay, get down. No, not on the arm of this. Right now. Get down on that chair. On that chair. I know. Okay, either watch your show or you sit on the chair. All right, here we go, everybody. So this should say x times the cubed root of 2y times the cubed root of 4x. That's a squared y squared. Okay. Okay. So I am going to choose. There's a couple of ways that I could do this. I am going to choose to convert them to rational exponents. Okay, there's lots of different ways that I could do this, but I am going to make that choice. So I'm going to say I have x times 2y to the 1/3 power times 4x squared y squared to the 1/3 power. Okay. We now are allowed to, remember from what we learned last week, distribute those exponents through this. So I have x times 2 to the 1/3 times y to the 1/3 times 4 to the 1/3 times x to the 2/3, because I multiplied 2 times 1/3, y to the 2/3. Crazy looking, right? And these are all multiplies in here. Okay. When we are multiplying and we have bases that are the same, what are we supposed to do with our exponents? So what am I supposed to do with my exponents right now? We only have like 4 options, right? Add, subtract, multiply, divide. So what are we going to do? What do you guys think? Tell me in the chat. I am hoping we have to lay this morning. There we go. We've got good. Hopefully we watched the lesson on Friday, because that was in that lesson on Friday. Okay. You had to watch the first half of this on Friday. All right, so we are in fact going to add. So I noticed that this base and this base are the same. Since this is technically a 1 exponent, I'm going to rewrite it. Just Mikey, stay here. Mikey, stay here. Okay, Andy, back up, back up, back up, back up. Okay, come around the table on the bench and get away from the glass. You have bare feet. Okay, Mikey, come here. Come stay over here on the sofa. I'm sorry, we just had a break. Hey, Andy, you need to hurry. You have class. Okay, don't walk back in there. Just you can fill your glass with water and take it upstairs. Okay. All right. I'm sorry. We just have broken glass in the kitchen. The fun and exciting ventures of working from home with kids. All right. So x to the, I'm going to write this out. Probably I would do it in my head. Okay. So I see my x's I'm adding together. Let's see what else we got here. So we've got the y's we're going to add together. So we've got y to the 1/3 plus 2/3. And then I have, so I've got a 2 left behind. Is there another way I could write this 4? Does anybody know another way I could write that 4 that might help me here? Tell me in the chat, what do you guys think? Is there another name for 4? Oh, 2 times 2. That's a good one. Is there another way I could write that? 2 plus 2. Okay. Could I write it with an exponent? Is there a way for me to write it with an exponent? So go back to your 2 times 2. There we go. Nice job. There we go. 2 squared is what I'm going for. So I could rewrite this 4 as 2 squared to the 1/3 power. Okay, so I'm going to need a couple more steps here. My x is going to become x to the, when I add it, 5/3. And then y to the 3/3. And now we have these bases the same, right? They're 2. This is technically 2 to the 2/3 power. So I'm going to be able to add those exponents. So 2 to the 1/3 plus 2/3. Okay, so my final, hopefully close to final answer on this is I've got x to the 5/3, y to the 3/3, which is just going to be y to the first, and then 2 to the 3/3. Notice I left that up top, or up to the 3/3, which is just going to be 2 to the first. So that's probably how I would write my final answers, like that. Okay. All right, let's try this again. All right, a little bit different, and every single problem is going to have its own little twist. Okay, so you just kind of have to take what we learn in class and apply the methods. Try something. If it doesn't work, try something else. Okay, so I'm not going to do the roots. I'm going to go with my fractional exponents again. So I'm going to go 64y. How do I rewrite the square root? What's the exponent supposed to be for a square root? Can you tell me that in the chat, please? What's my exponent supposed to be on the square root? Let's think again. What's the exponent? My new fractional exponent. 2 is almost there. What's my new fractional exponent that I would write? Not 3. It's got to be a fraction. There we go. Now we're getting it. Remember, you have to convert to a fractional exponent. There we go. Okay. This is making sure we're awake this morning and we're checking our understanding on this, right? It is Monday morning. However, it's 9 o'clock on Monday morning, right? If we were actually on campus, we would be done with this class already and you'd be in second period, okay? Think about that. See, at home you get to be, you don't have to get to school till 9 o'clock. All right, this is to the 1/3 power, right? If we're going to make it into a fractional exponent. Okay, so I am going to distribute these in. I wrote way too big. So I've got 64 to the 1/2, y to the 1/2, over 64 to the 1/3, y to the 1/3. All right, we are dividing, and I'm going to look at my bases being the same. Okay, when I am dividing, what do I do with the exponents? Do I add, subtract, multiply, divide? One of those 4 things. What do I do to my exponents? All right, it was apparently a really long weekend. Okay, so I thought I brought it up in the lesson, but hopefully we didn't apparently watch the lesson. When we have a division sign, it's the same as like the horizontal as a subtract sign. So we should be subtracting the exponents. You guys need to make sure you actually do the lesson ahead of time because it doesn't make the next lesson very easy if you don't do it ahead of time. Okay, so we are going to subtract the exponents here. So I have to do 64 to the 1/2 minus 1/3 because these bases match. And then I'm going to do y to the 1/2 minus 1/3. I am going to have to get a common denominator. What's my common denominator going to be? Can you guys help me with that? What's my common denominator going to be for both of them? Ah, we've redeemed ourselves. There we go. 6. Okay, it's going to be 6 all over the place here. All right, so 1/2 would be 3/6, 1/3 would be 2/6. So let's see, 3/6 minus 2/6 would be 1/6, and that would be 1/6 here. Now, that might be a perfectly good answer. However, when it's numeric, we need to simplify as much as we can. Go back to Friday. I want you to find the list we put in the left-hand column. I think we put a list in the left-hand column. Where did it go? So on this one, there it is. Okay, I want you to go find that list. Okay, is there another way that we can write 64 that would help us right here? So tell me another way we could write 64 that would help us. So right now we're to a 1/6 power. Ah, good, 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 good. We're going to write it as 2 to the 6 to the 1/6 y to the 1/6. These cancel, so we get 2y to the 1/6 power. And again, I don't know off the top of my head how it is an HMH assignment is going to have you do that. You could also convert it back to the 6th root of y. Okay? All right, let's do a couple more of these. Okay. So I am looking at 5 here. It's the square root of x cubed over the cubed root of x squared. I bet they thought they were being funny when they did that. Okay, so let's see if we can remember. What in my numerator here, what should my exponent be? So in the numerator, what's my exponent when I convert it from radicals to exponents, to fractional exponents? What do you guys think? I just want the numerator. And I have a little bit of discrepancy here. I don't have any answers that match yet. So I'm going to wait for a few more to answer. Skim back up a little bit. Look at the notes that we did last week. Remember where the root goes. Where's the root go? So what's in the root, it's kind of like where the roots are in a tree. So what do we guys think that exponent is? If anybody who's already typed it in wants to revise their answer, they can. Ah, Matthew, thank you for revising. I'm gonna wait another minute here. Make sure you're helping me answer this. I'm looking for the new exponent of the numerator. Okay. Okay, so we're gonna try this. So remember out here, in this, there's an invisible 2. Okay. Roots are at the bottom of trees, right? So whatever's in the root goes at the bottom. Ah, there we go. So we're gonna have, not quite. The root is at the bottom. So my exponent 3 is at the top. My root is at the bottom. Okay. You have to know this for Monday. Easiest questions on the test, right, are going to be convert. So you need to make sure you know this. Plus, you're going to have to do it within some of the harder problems. You've got to make sure you can do that. Okay. Let's see if you guys can redeem yourselves because we didn't do very well in the numerator. What should the denominator be? So tell me what you think the denominator should be. X to the what? Just give me the what? Just give me the exponent. Ah, yes. You guys have a case of the Mondays today, I think. So, because you were doing really well on this stuff when we met on Thursday. So I think we have a case of the Mondays. Okay. So let's see if we can get rid of the case of the Mondays. All right. Let's see again. Let's see if we can remember what we did an example ago. When I have division, what do I do with my exponents? Add, subtract, multiply, divide. What do you guys think? Tell me in the chat. All right, nice job. We are going to subtract. So we've got x to the 3/2 minus 2/3. I'm going to use 6 as my common denominator again. Let's see, I have to multiply by 3, so 9/6 multiplied by 2, 4/6. Make sure my arithmetic's right, because sometimes I'm wrong. X to the 5/6. Okay. How are we doing on time? Oh, we're still good. All right, we'll make it. All right, let's take a look. I'm going to pause for just a second and let you guys finish writing, and then we're going to take a look at number 6. Okay, so my goal on number 6 is first of all to convert it to fractional exponents. Okay, so I've got 16 to the 3/6 times 4 to the 6/4 times 8. What's to the 2/3 power? Okay. I now would really appreciate it, okay, if we could get the bases the same, okay? So what number do you think I could make the base on all of these? What number do you think the base should be? We're not looking for a common denominator. We're looking for a number that we can raise to an exponent that's the same on all of them. All right, let's go back to powers of 2 again. So we know that 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. Is it making more sense now, I hope? Okay. So I could rename 16 2 to the 4th. And then to the 3/6 power. Okay. I could rename 4 2 squared. So 2 squared to the 6/4 power. Okay, tell me what's the name for 8? Can you guys tell me what the name is for 8? The new name for 8. All right, nice. We're going to do 2 cubed. Okay. Now, we can cancel. I know, those are mommy's notes, aren't they? Those are mommy's notes. Okay. So we're going to do, we're going to remember this is like a numerator. We're going to cancel with the denominator. So I know 2 goes into both 4 and 6. 2 goes into 4 twice and into 6 3 times. Oh, and check this out. Then the 3's cancel. So it looks like I get 2 squared out of this first one. Okay. Then I get, let's see, 2 goes into 4 twice. 2 goes into 6 3 times. It's 2 cubed. And then my cubes cancel, so I'm just left with 2 squared. Okay. When we are multiplying our bases, what do I get to do with my exponents? Add, subtract, multiply, divide. What do you guys tell me? What do you guys think? Add, subtract, multiply, divide. Oh, we're not touching on the screen. All right, nice job. We are going to add those exponents up because we have the same base of 2. So 2 plus 3 is 5, plus 2 is 7. So all I need to know is what 2 to the 7th is. Can you guys help me out? What's 2 to the 7th? What's 2 to the 7th? Tell me in the chat. You can look it up. You can use your calculator. It's okay. I don't know what, or you could just multiply the 64 by 2. It's on to the side there. You let me lose my spot, dude. Uh-oh, where did my people go? There they are. Oh, we've got a few people. We've got a few people. 128. Nice job, everybody. Okay, we could add that to our powers of 2 list, huh? All right, we're going to switch gears just a tad, tweak it just a little bit. Okay, so we are going to simplify radical expressions using properties of nth roots. Okay, a little bit different. We're going to probably see a little bit more algebraic stuff in here, I think. Yes, we're going to see some more letters, less numbers. So what it's saying here is we have to have, let me think about how I'm going to explain this for a second here. All right, let's go back to, I'm going to go back to like 12, okay? I know that I can break that up into 6 and 2 and 2 and 3, right? So I know that that's the same thing as saying 2 times 2 times 3, which means if I'm going to take the square root of that, one of these comes out. I do this a little differently, right? I get to bring one out, so it's 2 squared to 3. The way I do it is I say, hey, and we've seen this before, what's the biggest square number that goes into 12? How many times 3? So 2 squared to 3. So that's what this first property is saying, is the nth root is a product of equal to the product of nth roots. So this is the nth root of AB. It's the product of the nth root of A times the nth root of B. The catch is, let me look at this one here. So it's the cubed root of 16 equals the cubed root of 8 times the cubed root of 2. So those roots need to be the same, and they need to multiply up to this number. Basically in here, I'm going to find the biggest cube instead of the biggest square. Biggest cube that divides. So it's 2 cubed root of 2. All right. And then here is the quotient property. And again, the nth root has to match a over b, nth root of a over the nth root of b. Okay, so let's try some of these with examples. I know my phone's going off, but I'm not going to answer it, dude. Okay. All right. So let's try this a little bit. So I'm going to start with a here, and a is the cubed root of 256 x cubed y to the 7th. All right, so I'm going to do my can and my can't do box thing. Okay, so I can take a cube root, okay, or I can't take a cube root. Normally, I don't write out quite that much. So cube root. So something that I can obviously take a cubed root of. So I'm going to divide up the 256. I'm going to go through my cubes list, right? 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125, which is not going to divide. So I think this divides the 256. So I'm going to do 64, and I know it goes in there 4 times. 64 times 4 is 256. So I can take the cube root goes in the first one. I can't take the cube root goes in the second one. For the exponents, you're going to pull out multiples of 3. So I know that I get all of x. Okay. For the y, I'm going to get y to the 6th, and I have y to the 1st left over because 6 plus 1 equals 7. Okay. I'm going to take the cubed root of 64. Can you guys tell me what's the cubed root of 64? Help me out in the chat. I want to make sure you're still paying attention. So what's the cubed root of 64? All right, good job. It's 4. Okay. To take the cubed root of these exponents, you divide by 3. You divide by whatever's in the root. So it would be x to the 1st, or just x, y to the 2nd, and then this stuff stays in the root. Cubed root of 4y. That's it. Okay. We're going to try it again. The more of these we do, the better. Okay. The more you see, the better. All right. Let's take a look at this one. This one says the 4th root of 81 over x. All right. This one is really, really weird. Okay. So the first thing I'm going to do is I'm going to break up the numerator and the denominator a little bit into the 4th root of 81 over the 4th root of x. And we're going to do a process called rationalizing the denominator. Okay. Let me explain it really quickly with squares, and then we'll deal with it with the 4th root. Okay. So if I had like a number 10 over the square root of 2, okay, in order to rationalize the denominator, meaning I don't want any radicals in the denominator, I am going to multiply top and bottom by that radical. It just so happens that this exponent and this exponent end up adding up to 2. Okay, so I would get 10 square root of 2 over a radical times itself would be square root of 4, or just the number under the radical. And then we could simplify more. Okay, so for this one, what I need in order to rationalize this denominator with a 4th root is, in order to multiply, I need this to add up to whatever's in the index. So if this is a 1, what number do I need to put on this other x if it has to add up to the index? Can you guys tell me? What number do you need? What do we think? What number do I need if we have to add up to the index? I have a 1. Index is 4. What do you guys think? All right, we always want to keep it positive. Thank you for those of us that are being brave right now. It is in fact a 3. Okay. So, and whatever I do on the top, I do on the bottom. So it's like multiplying by 1. And I know this seems really weird right now. Okay. So what this is saying when I multiply across the top is that I have the 4th root of 81 times the 4th root of x cubed over the fourth root, x to the first times x to the third is x to the fourth. Okay, help me out in the chat. Let's see if we remember this or if we can go back and look it up. What's the fourth root of 81? We wrote it down last week. What's the fourth root of 81? Think about power to 4. Oh, we got a couple people. Oh, yes, it is 3. You should know that one. That one's when you got to know, okay? I can't do anything else with this. It's as simplified as it's going to get, so we're going to leave it as the fourth root of x cubed. The fourth root of x to the fourth would just be x. And that's how we would leave this. Okay? All right. We are going to skip the reflect. Okay? So I'm going to skip the reflect. You can cross-reflect out. Okay, let's look at a couple more of these. Okay? They get a little bit uglier. Let's see what we can do with them. Well, actually, the first one doesn't get uglier. The second one does. So the first thing I'm looking for is, this is a cube root. So it's a cube. Oh, that's terrible, Mrs. Beller. It is a cubed root of 216 x to the 12th y to the 15th. The cubed root of 216 x to the 12th y to the 15th. All right. So what is the cubed root of 216? Do we have a number there? What's the cubed root of 216? What do you guys think? Do I have to do can and can't do box is what I'm really looking at, or do I have perfect cube? So look it up on our chart. What's the cubed root of 216? I think we have that in our chart. If not, you can use Desmos, your calculator. I've got a couple answers. Let's see if we all agree. Nice. It is in fact 6. Okay. Okay. Then, you got a phone number? Whose phone number do you have? My phone number. What's your phone number? 888-116-228. That's pretty good. That's a pretty good phone number. Okay, thank you for sharing. All right, so with that was the brain break right there, guys. Okay, so with this here, if I'm taking a cubed root, what do I need to divide those exponents by? What number? Tell me in the chat. What number do I need to divide those exponents by if I'm taking the cubed root? No, Mina, give me a few more minutes. Give me a few more minutes. All right, nice job. We're dividing by 3. So I've got x to the 12 divided by 3 is 4. Y to the 15 divided by 3 would be 5. Okay. All right. Now we're going to go over here. This one's quite a bit uglier. Okay, so fourth root of 16 over x to the 14th power. Okay. Yes, I see. So I'm going to start. Oh, which one do you think is funny? Stitch? Yeah. Okay. So I think that one is Andrea, or Mikey likes your avatar. He says Stitch is the winner today. Okay. We all have to change it. You see, I changed mine to Valentine's avatars now. Okay. I've got to go with the theme. So I'm going to start by trying to simplify this as much as possible before I rationalize it. Okay. So what is the fourth root of 16? Can everybody tell me that in the chat? What's the fourth root of 16? All right, nice job. Nice job, everybody. Have you noticed that most of it comes down to 2 and 3? Okay. A lot of it is at 2 and 3. So those are really important that you know your powers of 2 and your powers of 3. Okay. Andy, be very careful. I have not gotten to clean up in there. Okay. So you got to kind of walk around. Don't go put shoes on, please. Okay. All right. So I am going to split the fourth root of 14 up. Okay. So I need the biggest number that divides 14, that's divisible by 4 that's in 14. So I'm going to pull out 12. So what value would I put on this other exponent? Tell me in the chat, what value would I put on that other exponent? What do you guys think? Remember, they have to add up to 14. It is, in fact, going to be 2. I'm going to go back and look at this chat, and I'm going to go, it's all 2s and 3s. It is in fact a 2. Okay. Now I'm going to take the 4th root of x to the 12th, which is going to be x cubed, right? Because I divide it by 4. And then I've got this 4th root of x squared. The problem is they're not going to leave a radical in the denominator. So I need to multiply top and bottom by a radical. So I now need to look at this index and this index here. These guys have to add up to the index outside. So again, I'm going to put a 2 in there. Alexa, alarm off. Okay. That's going to be a 2. All right, so across the top, we've got 2, 4th root of x squared. I'm sorry, I yelled in your ears, guys. All right, and then this is just going to be x cubed to the 4th root of x to the 4th. What's the 4th root of x to the 4th? Can you guys tell me that in the chat? The answer is not 2 or 3. It's the 4th root of x to the 4th. There we go. Good job. It's an x. Okay. And then we're going to, when we are multiplying, we are going to add these exponents. So I get x to the 4th. And I believe that that is going to be as simple as you can get it. Okay? And that's it. That's what we've got for today. I'll leave it there for a minute to make sure you're caught up and have written it up. Okay? All right. And I think I crossed out a few of these down here. So let's look at the summary. You can cross out 13 and 14 on your summary. Okay? So just do 12 and 15. All right, so cross out 13, 14. Just do 12 and 15. All right, so let's take a quick look at what you have left to do. I can go back up. Yeah, sorry, I was going a little too fast. I'll be quiet for a minute. Let you guys write. I was going too quick. All right, we got it. We ready? Okay, so we're going to go to, let me go really quickly, cross out 12 and 13. Correct, Javier. Thank you for putting that. Oh, no, wait. Cross out, no, not 12 and 13, 13 and 14. Cross out 13 and 14. There we go. Okay, that wasn't it. 13 and 14. Not 12. Okay, all right, let's try this again. So I'm going to go over to Google Classroom really quick. All right, so you're still the only ones with the fancy header, okay, the fancy banner. All right, so today what you have to finish, okay, is you're going to go also watch the lesson for 7.7 or explore and explain 1. If you don't do that before Wednesday will be super confusing. Okay, so you need to go do that before Wednesday, all right, before you come into class. And then you're going to work on homework number 20 and you're going to turn in homework number 21. Notice I said here we're doing a test next Monday. Okay, we don't, our review time is Thursday for that. So I will publish a review hopefully I'm super good tomorrow, if not for sure Wednesday. And we will be going over questions / reviewing for the test on Thursday during class. Okay. All right. And then everything you need is posted there. Let's do the joke of the day. Okay. Are there any questions, comments, concerns that we have? All right. He needs to do, he's getting a little lazy on his jokes here. Getting a little lazy. I gave him a website to go look up jokes, and then of course.
Hey guys, now we are going to do some Valentine's jokes 2 a day. So yeah, let's get going here. So what did one boat say to the other? Are you up for a little romance? Now for the next one. How can you tell if a calendar is popular? It has a lot of dates.
Hmm.
Yeah, it's popping up right there. So yeah, thank you for letting me share this with you. I'll be back with 2 more tomorrow. And I'll be here all week. Because I live here.
Because I live here. All right, yes. He will be here all week. He rarely leaves the house. He's my non-outdoorsy child. These other two, they go out all the time, huh? You want to be outside all the time. All right. So that's what I have for you today. I know we're out a little bit early. I'm sorry that we are out a little bit early. I know you'll be all upset about that. But I will see you on Wednesday. Please, please, please make sure you get all your work done and you watch that next video, okay? Because we're taking a test on it on Monday, ready or not. Okay? Have a great day. Mikey, can you wave goodbye? Wave goodbye. Bye. See you on Wednesday. I'll be hanging out. So if you need something, you can stay behind and I'll hang out. Yeah, what's that? I don't know what that is, but it's gone now because they all said goodbye. They all said goodbye. Oh, that's mommy's. I made it a heart now, huh? Isn't that cool? Yeah. All right. We're gonna hang this one up. Oh, we gotta stop the recording. Stop recording.